be ready. So, yeah, he's getting it now. So, hey, look at that. All right. So this is Douglas Sellers. He is the lead technologist for CustomInk.com, a website that enables people to design and order custom decorated products such as printed t-shirts and embroidered caps for their groups, events, gifts, self-expression, and, well, I guess other things. So over the past year and a half, Doug has led the development and testing of a large AJAX application, the CustomInk Design Lab, using Ruby on Rails and Selenium, as well as numerous other Ruby-based projects. Before coming to CustomInk, Douglas was a hardcore Java programmer who was a technical lead for the development of a native XML database, as well as for numerous other successful web and non-web-based projects. Other than programming in Ruby, he enjoys eating sprinkled cupcakes, large Lego-based construction. You don't eat those, do you?
No, I don't.
No, oh, okay.
Cupcake shape.
And free t-shirts. So join me in welcoming Douglas Sellers.
Hi, everybody. Really, today I'm here to talk to you about our experience with testing our AJAX, our large AJAX application, and the reason that we ended up eventually using basically domain-specific languages in order to do this. And really, if there's one thing that I want you to take away from this, it's just that writing Selenium tests is hard, and you have to build something on top of it. We heard Apple talk last night about how they built their own framework on top of it, and this is sort of a different approach, but along the same lines. But really, the lesson learned here is that you have to build something on top of it. You want to get away from writing Selenium tests directly as quickly as possible, and what approach you choose, it doesn't matter as much as the fact that you pretty much go that way immediately. Okay, so I work for a very small, or not a very, I work for a smallish company called CustomInk.com. Really, we make online custom apparel. We let people in the web browser design different pieces of apparel. And when I say apparel, it's 95% t-shirts. And they build everything in the browser, and I'll show you a little demo of that in a second. The thing to really note here is that we do a lot of business over the web, but we only have about 5 software developers. And we have no dedicated testers. Really, our dedicated tester at this point is the CEO, who tests it as soon as we do a rollout, and if there are problems, comes and has words with us. So really, for us, testing is about making tests as easy as possible to write. We have to really make it so almost anyone can write tests, so that the overhead with writing the test is very small because we have so few technical resources. But we do have other people in the company who can potentially write tests as long as there's a very low barrier to entry. So this is what I'm going to talk about. Really, this talk is divided into 2 big parts. The first part is really just me trying to convince you that DSLs and Selenium go well together. And the second part is more about how we went about writing our own DSL and how you could go about potentially doing this in your own company. So here, I brought an example. So this is an example of something that got returned to CustomInk. And for anyone who can't read it, it says, Crystal Ballin %27. So when we first got this back, we thought for a second, maybe that's what they want. Maybe they were clever HTML developers, and they wanted to abbreviate an apostrophe with a %27. After we talked to them, that isn't what they wanted at all. The biggest problem here really is that CustomInk gives away all of the returns to the employees. So when we got a box of 50 of these back, people are still wearing these things around the office all the time. So every time I see one, I basically have to hang my head in shame because it's a bug that we didn't catch. So this is the CustomInk Design Lab. And really, the reason I'm going over this is because our DSL has a lot of very specific terminology in it that's specific to our business application. And I just need to introduce you to a couple terms that we use so that you can understand how our DSL works. So we call this guy Ichabod for obvious reasons. We call the pieces up here, these we generally call tabs. And we refer to the main things that people do is they add art, they add text, and they add personalization. Where art and text are self-explanatory, personalization is putting like your own name and number on the back of softball shirts. So this is what we allow people to actually upload stuff. We allow a lot of customization of text as well as color selection and all that kind of stuff. This is our most common example. We call it the bird clip art. It's my personal favorite piece of clip art, so it gets used in a lot of tests. And these are sort of the options that you actually have when you're working on clip art. I guess that one didn't happen. Well, that one was going to be a picture of a Frisbee, and it was with text on it. It was just meant to show you that we're doing a lot of different types of products in this. And it pushes a lot of complexity into the JavaScript. This application is probably 50% JavaScript and 50% server-side Ruby on Rails, as much as Ruby on Rails is server-side. Testing that complexity in the JavaScript is really where we ended up with a lot of trouble, especially since it was so asynchronous. Really, we're only ever loading one page. In more traditional web-based testing, you use the page transitions as sort of your state demarcations, so you know you're in a next state once the next page completely loads. We don't really have that. All that we really have is one page that loads and then lots and lots of asynchronous calls that happen that dynamically modify the DOM. So we started this project probably about a year ago, where we've been working on it probably a year and a half, and about a year ago we decided we really needed automated testing, and we sat down and we came up with exactly what we're looking to get out of our automated testing. The most important thing here really is that the tests had to be easy to write. We knew that the tests were going to have to be easy to write, because really, if the tests weren't easy to write, no one was going to write tests. And then it was going to be me, literally Doug, who was going to be clicking through the entire application every time we wanted to do a deploy. And we knew we needed to be more agile and faster with our deploys. So we wanted to make it as automated as possible. Another thing to note is that anything that is not tested by our automated framework, I have to go through and actually test by hand. I actually go through and black box test. So there's a lot of motivation for me to make it work as well as possible. Obviously, it has to run in multiple browsers. We're supporting right now Safari, Firefox, and Internet Explorer. So when we started, we looked at a lot of existing toolkits that were out there. What we found in general was that they provide very good technical, generic functionality. If you want to click on a link or select a div or even do a drag drop, I mean, that's straightforward to do in almost all of these frameworks. So when we initially started, we thought that was going to be enough, but we quickly found that that's just too fine-grained. And eventually, we went even farther and realized that the goal of the person writing the framework and our goal as testers are basically at odds. The framework writer is trying to write something that can be as generic and applied in as many situations as possible. And we want just the opposite. We want something that's extremely specific to our own application, to make our test writing easy. I think that's why a lot of people end up developing frameworks from scratch. It's just because they know exactly what they need, and rather than trying to make the generic functionality work for them, they just develop their own specific functionality. Most of the existing frameworks are also still based on page transitions as state demarcations. I'm going to talk about this a little bit more. But that really doesn't work so well for us, and I understand it's a very hard problem, and all the toolkits provide some way of dealing with asynchronous calls. It's just how well can you make that work for you. So this was our first try at writing a Selenium test. About a year ago, our lead JavaScript developer and I sat down and tried to write one, and I'll keep you from straining your eyes here. Do not look at this. The whole point is that this is very complicated. It has lots of embedded JavaScript. We're using store a lot to keep sort of the position of clip art. And we wrote one of these, and we realized very quickly that we weren't going to write any more. We had to find a way to make it easier. It took us a couple days to get that. And even then, it didn't really work so well. It was just too complicated. Our DOM is too complicated. The JavaScript we're running is too complicated. Building the wait fors by hand and writing all that JavaScript was very error prone. We ended up with asserts everywhere, and we were inconsistent with our use for asserts, and most importantly, it was really hard to do. So next, we did what we thought was the next logical thing. We went out and we tried using the Selenium IDE. And I should back up and say, at this point, we had chosen Selenium mainly because at the time it was all that supported all the browsers that we wanted to get into, at least any of the open source tools. So it has something called the Selenium IDE, which is kind of a recording tool and kind of just a way to easily select what you're manipulating and write the commands in a more friendly a more friendly way. Normally Selenium, in very basic Selenium, you write it in a table format, basically. You give it HTML that has 3 columns. The first column is just the command, and next two columns are the parameters. This takes a step up from that, so you're actually working in a little IDE. Looking into the DOM was a lot easier. It still wasn't as easy as using Firebug, but it was a lot easier. Dealing with asynchronous events was still a pain. Writing custom JavaScript was a pain, and tests were still really hard to write. They were very time-consuming to write. They were very brittle. So next we tried what we really thought was going to work. Was we tried using something called the user extensions.js, which is part of Selenium. And all that really is, it's a way that you can write your own custom Selenium commands in JavaScript and have Selenium recognize those commands. That didn't work too well for us either. We found that actually writing that JavaScript base was painful because it wasn't like writing normal JavaScript. You had to take into account what Selenium was doing at all times, and the timing between everything was very easy to screw up. It did allow us, though, to roll things up into single commands, which we thought was very powerful. So rather than saying click, 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 we could actually tell it just to go to one page at the end. But it was still really hard. Writing that JavaScript was just unmaintainable. We actually got a little farther. We probably got 3 or 4 tests written this way before we just punted on it. So what we learned from the first 3 tries was, first we learned that we had to be able to test in all these different browsers. Even based on the few tests that we wrote, we knew there were going to be lots of timing issues with our AJAX stuff, and we knew that was going to be one of the biggest problems. We knew that the way that you're managing state transitions was very difficult. It's hard to know when an asynchronous event is done, and if you have to hand code that every time, that's very slow. And we also started to realize that we were testing more of an application than we were really a website at this point. And we started to run into a lot of some problems that you typically run in application testing. We started to run into race conditions. I say multiple threads because there are obviously no real threads in JavaScript, but certainly some things were returning faster than others, and we had multiple things going on. We started to run into memory leaks that were happening as different things occurred. So we need a way to test this more like an application and less like just a web page. Okay, so we sat down for our fourth try, which eventually worked, and we came up with a strategy. First, we just admitted up front that when Selenium tests were actually in the browser, they were going to be ugly. There's no way we were going to get around that. At some point, it had to compile down to the most basic technical functionality. We thought of it like compiling C++ to assembler. Yes, it's much easier to write in C++, sort of, than in assembler, but in the end, it all compiles down to that. We still really liked Selenium, though. It provided all the functionality that we needed. It ran in all the browsers that we needed, so it's just a matter of getting it so it was much easier to write. We liked what we came up with as far as rolling up lots of commands into a single command, or lots of complexity into a single command when we did our JavaScript attempt, so we thought we'd keep that. And eventually we decided we were going to try to develop our own domain-specific language. I think that decision was helped along by the fact that we were a Ruby on Rails shop, basically, and Ruby is very nice for writing domain-specific languages. It has a lot of nice syntax that makes it easy, which I'll show you in a second. So so we went and we wrote one test, and this is what it ended up looking like. It really read very nicely. It really was in the vernacular of our business. As you can see, like, I think the second command is a good example where we say select tab. Tab can mean a lot of different things in a lot of different contexts. But when people talk about the lab at CustomInk, that's how they talk about it. They talk about it in terms of tabs and, going from one tab to another and adding clip art or adding text. So we made it match that exactly, and the way we did it was we first sat down and we wrote this, and then we tried to figure out how to actually make it work, which we could. And I'm going to talk about DSL commands also, and whenever I say that, really, I'm referring to the verb in here, or the action that's being taken. It's usually on the left-hand side, exactly what's going on. So in this case, load lab or select tab. And all this compiled down into this. So we really had cut down on the amount of complexity that we had. we had really cut down on the amount of verbosity that we had, and we thought that we had really made it a lot easier to write. Okay, so now I'm going to give, before I really get into exactly how we did this, I just want to tell you what domain-specific language means to me. I mean, it means different things to different people in different contexts. So to me, it really is a way to write, to have a language that allows you to speak in the language of your business. So when you read programs, they're going to read as if they're going to make sense in the context of your business. It's not going to be, you know, do this, then click on this link, then wait for this, then verify that it actually got added. It's going to be add clip art, and it's going to just figure out how to do that. It also is generally built on more generic languages. They usually don't compile down. I mean, I guess some do, but mostly they're built on top of more scripting type languages like Ruby or Python or Groovy. And really, our goal is to try to just make it read as much like sentences as possible. I mean, that was sort of our idea when we started. Also, it makes writing these tests much more accessible to non-technical users, but it also makes it accessible to different kinds of technical users. So in our application, the JavaScript and the DOM was very, very complicated. And not everyone on our team, even though our team was only 5 people, not everyone on our team had that knowledge. In fact, really only one guy had that knowledge that was detailed enough to actually make a lot of these tests run. But we wanted everyone to be contributing tests. And that was going to be either a big cross-training problem or it was going to be a way of hiding that complexity. So yes, it did help us with less technical users, but it also helped us with different kinds of technical users. So here's some technical details about our DSL. We wrote it in Ruby using something called Selenium on Rails, which is great. What Selenium on Rails is just a plugin to Selenium, or excuse me, into Rails, and you do not have to have your entire project in Ruby or on Rails for this to actually work. This can work with pretty much any project. You just have to be willing to proxy some things a little differently. It basically has to be on the same domain as your tests are running on. Our emphasis is always at this point on ease of test writing, not on ease of DSL maintenance and writing, which is an important point because at this point, we were willing to trade complexity in our DSL and complexity in our framework for actual ease of test writing. Our focus was always on how do we make this easier to write? How do we make this easier to write? How do we make it so we can get a bug ticket that comes in and easily translate that into one of these tests? So we've jumped through a lot of hoops to try to make that happen. It's also made up of just 2 big parts, our commands and something called partials, which really are just templates in Rails. So whenever I say partial, think template. And something that we wrote called page state, which is really how we manage all the state transitions, which I will get to in a second. So here's our actual test again, and I wanted you to notice a couple things when you look at this. First, there's no JavaScript, there's no CSS selectors, there's no div IDs, there's no XPath. There's no technical details in there. The closest we have to actual technical details are this right here, which is the ID for the clip art, and we've thought about trying to pull that out too, but it's just not worth it at this point. It would be really hard to do, and people already sort of understand how this works anyway. Also notice that when you transition between the states, so what I'm really talking about here is I'm talking about select tab, click link, click link, click link, that those link names can mean different things in different contexts. So browse gallery means one thing when you're in the add art tab. It means another thing when you're in the personalization tab. So we had to be able to understand where we were if we wanted to actually get all that technical complexity out. But really keeping the technical complexity out of this is a big win for us, just because when we did initially develop this, our application was changing a tremendous amount. And I would encourage everyone who tries to do this to try to develop this as you're developing your project. Don't wait until the end. Do it in stream. And it's going to force you to keep the technical complexity out of the DSL, or you're going to drive yourself crazy trying to keep it up to date. Excuse me. So that's really what we were striving for, what I think we accomplished pretty well. One of the big signs that we have is whenever we start to see div IDs or JavaScript or anything like that creep into these tests, and it does happen, then we know it's time to add more commands. At this point, I think our DSL is somewhere between 60 and 80 commands, and I'm very willing to add more. I think the last verification is a good example of that, where we're verifying centered. If you want me to verify left or verify right or verify top, I'd rather have a command like that than try to push a lot of complexity out into the DSLs. Here's what I just said. Okay, so now I'll walk you through how one of our commands is actually implemented. So I'm going to walk through load lab. This is the Ruby for load lab. I know not a lot of people really know Ruby, but it's a very simple language. And the thing to notice is first that the first 6 or 8 lines are dedicated toward just how there are optional parameters you can pass in Ruby and how the optional parameters are managed. So we're really doing conditional logic in our test to determine exactly what they're trying to accomplish here. Then on line 675 down here, we have our page state, and then we just build the URI, we open it, and then we include one of those templates that actually has all of our nasty JavaScript and waiting logic. And that compiles down into this. The interesting thing here is that one command has 4 waits and 3 asserts in it. And this is one thing that we found over and over, is that basically you can never have enough asserts and enough waits. So the more asserts that you have, the more that the verification is actually going to happen in each step of your test. And the more that people reuse that command, the more inline verification you're happening based on different states of the application. The more waits that you have, the less likely you are to run into timing issues. It's the single biggest problem we still have in this, is that it's hard to get all the timing issues out in all the browsers. Every time we run it in a new browser, there are always some timing issue that we have to try to get out. But at least I feel like we have a way to attack that problem. We aren't attacking it in the actual test. We're attacking it in the framework for our DSL, and that just sort of naturally gets built in. Okay, so this is the most complicated thing that we really do. We built something called the page state object, which is really just a state machine in memory that models exactly what each one of the states in the application are. And it just tries to model 3 things. First, what's the name of the current state? When someone does a click on that state, and because most of this is just very click-based, when someone clicks on that, what do we need to do in order to verify that that has finished completely running? And then what do we need to do to verify that it's in the correct state when it finishes? So, and I don't know if this particular description is going to help a lot of people right now. I mean, this is kind of a more technical piece of it, but if you try to do this, this is going to help you if you come back and look at exactly how we did this. At least it'll give you some ideas as to how you can manage a lot of these page transitions. So in most cases, we just name the states the same things as the links, so that when people try to invoke it, they can just say click link and then the name of the actual text associated with the link, and it'll figure it out. So the reason we end up using an actual state machine and not just a property file is because of the different contexts that we end up with for each state. So browse gallery, again, means something different in this context than it does in other contexts. So it all has to be hierarchical in some sense. This is what our click config ends up looking like, and it really is just a flat state machine. If you look at something like add art, when someone clicks the add art link or a link named add art from the beginning state, we wait for the div name lab palette add art to be visible. We then run the partial, so we run this template which says select tab add art, which does all the verification and waiting to make sure it's in the correct state. And then we transition to the next state, which is add art, which then has all of the actual links you can click in add art and where they would transition to. Most people think this is going to get really out of control and really humongous. For our applications, it's probably around 300 lines. We don't generate it at this point, and we've talked about generating it, but it just is too much of a problem to generate really at this point. I mean, it's too hard to get it out of the JavaScript, basically. So that's what's happening. And what we also do is we also have something called default state. So in some of these, which I don't show, if there's no state or if there's a state so if you have a lot of things that do the same, like when you browse clip art, clicking on any clip art always does the same thing. So we just have a default state which it transitions to. But a lot of the complexity gets moved out of the DSL and into this configuration file. And when we actually want to make changes to the DOM or to the JavaScript, this is what we end up modifying the most. So at the end of the day, this is sort of the way that our DSL actually works. A Selenium test is requested by the browser. Selenium on Rails calls the tests RSEL tests. So it's rendered by Selenium on Rails, which executes our DSL commands as Ruby, which eventually tunnels down to just straight on Selenium commands. We use page state to manage exactly what state we're always in, so it knows what to put into the finished Selenium template. We hide all our wait for conditions or all our JavaScript into partials, because really moving JavaScript into templates, especially in this case, makes it very reusable as well as very easy to deal with, because you can just pass in variables that get included into the middle of your JavaScript. Eventually, the Selenium table and commands are rendered, and this is kind of important. Before, all of the conditional statements and loops and Ruby evaluation happens before the first command is run. So it really is compiling down to a static table and then is actually running it in the browser. We looked at possibly doing something using Selenium remote control, but it just added another level of complexity that we weren't really ready for at that point. And so far, this has worked fairly well. It also makes it much easier to debug, because we have a static Selenium file which we can always go back to and look at and try to figure out exactly what's going on. And then the commands all run in the browser. Okay, so now I'm going to talk just briefly about exactly how we went about creating our DSL. I can't tell you what you need to know to create a DSL here. You're going to have to go back and actually do research. I can tell you some of the lessons learned that we actually have. And I think the most important one really is just to make the language in your DSL just like your business. It's by far the biggest lesson that we learned, is just make it look just like your business. And I don't know if you're eventually going to get to where business people are writing it, but certainly the way that business people are going to report trouble tickets to you is going to be very easy to actually just take those and put them into a test. Some business people will take it up and actually try to write tests or make the browser do different things. The way we did it was we just wrote one test first and then tried to make that test work. I think if I was going to do it again, I would probably write 3 or 4 tests, just because one test doesn't really give you enough of a path through your application. It also depends on your application, but try writing 3 or 4 tests. Don't make them actually work. Just try to make them look like you want them to, and make the syntax right, and make it so you think it's going to be easy to write. Just try to get a rough idea. I mean, you're not going to write the whole thing up front anyway. At least I wouldn't recommend writing the whole thing up front. What you're going to do is you're going to probably write half a dozen commands first, and then you're going to just steadily add on to that. What you also want to do is you want to try to make the commands as coarsely grained as possible. So you always want to try to say what you're trying to do, not how you're trying to do it. Even in our example there, it maybe wasn't as tight as we could have had it, because we were still saying click on this, click on this, click on this. We didn't just say add clip art, which is probably the way that it really should read. But that's not always easy to do. You have to try to strive for that, and just to try to make the test as easy as possible. That really is the mantra here. The mantra is make tests as easy to write as possible, so you can get as many tests as possible, so you can get as much code coverage as possible. And you can start to use non-technical resources, or at least in our case, we can start to use some non-technical resources to do that, or at least we can have everyone contributing to the test suite. I guess that's not going to work. Okay, so I was going to do a little demo here of exactly how you would go about writing one for Google Maps, at least one command. And the idea is that if you want to do get directions, there are 3 or 4 different steps that you actually end up doing. You have to first click on the get directions tab, then you have to fill in the 2 boxes, then you have to hit get directions, and then you have to do all your asserts. And if you have a Selenium test, it's going to end up looking something like this. Maybe you aren't going to do the direct wait for page load. Maybe it's going to be more complicated than that. I also have pulled out a lot of the ugliest JavaScript out of this, as well as any additional asserts that you're actually going to want. So you're trading stuff like that for stuff like this, which in my mind, makes a huge difference. I mean, you're going from stating how something is being done to stating exactly what you want to do in the language of your business, so that you're moving all the technical details away, and you're just making it so that it actually makes sense to what you're writing, and it's very easy just to add tests. When we wrote this, we found that after we got it initially working, it was actually good for quite a few other things. We found that we could do a lot of the memory testing very, very easily, because in your DSL, at least when you write it using Selenium on Rails and Ruby, you have the full power of the Ruby language behind you. Just because you're talking mostly in your DSL doesn't mean that occasionally you can't throw in a for loop or a thread, or Selenium on Rails supports something called Fixtures, which is automatically loading data into the database, into the testing database for every test you're going to run, or if you want to pull data out of property files or out of CSVs. I mean, you can open files, you can do threads, you can do whatever Ruby can do in your DSL. So we found that if we wanted to do a memory test on adding clip art, no problem. We'll add 5,000 pieces of clip art and we'll see what the memory footprint looks like. Then we'll add 10,000. And it was easy to do. It was time consuming to actually run the test, but it was easy to do. And eventually we found that Selenium would almost debug itself as far as memory leaks, because eventually it's going to hit up against the timeouts. Once you start to hit the timeouts, you know sort of where the edges of your application are. And using just our DSL and just simple for loops in Ruby, we were able to do that. We also have taken a shot at using our log files to generate our DSL test, and that sort of works and sort of doesn't. We've always found that you're going to have more logging information. In some cases, we have enough to actually make it work. In some cases, we don't. But it at least it's been interesting to try, because the biggest problem we really have is reproducing user errors. So anything that can sort of help us automate that is good in our mind. And then this is also good for more than just AJAX testing. We started to use this basically for testing our whole site at this point. We found that it makes sense even on more traditional web-based testing to just be able to say, add clip art onto this piece of apparel and this color out of the catalog, without actually having to manage all the clicks that are going through. So, I mean, it made a lot of sense. We started just to handle sort of the asynchronous nature of our AJAX app, but in the end, it turned out to be really valuable to do lots of different things. I didn't know where else to put this slide, so I just put it toward the end. These are the lessons that we really learned when using Selenium. We found XPath locators they were too slow, especially in IE 6, which is really a dog. But we found that using CSS selectors was much, much faster, probably somewhere between 40 and 60% faster to use CSS selectors everywhere. So at some point, we went and did a big migration. And again, that was just a matter of migrating the technical details and the implementation of our commands, not our actual tests. All of these frameworks really provide only one or two constructs to just sort of bludgeon your AJAX app into submission. And in Selenium, it's wait for element or wait for condition. Or you can use wait, as people have talked about in the past, but I think that's a much bigger evil than just passing JavaScript in. It's just a matter of getting that JavaScript so it's as small a maintenance overhead as possible. And we found the custom Selenium commands in user extensions was just hard to write. So these are some of the problems that we're still having. We still have no way really of testing the UI other than doing some black box testing. And even that is hard because different browsers act really differently. Like IE6 on widescreen laptops with DPI at 125% displays much differently than IE6 at normal DPI. And it was really hard for us to find that bug because we had no way of automating that testing. And even if we did automate testing on that kind of an environment, it wouldn't have mattered because the technical functionality still works. You can still click. You can still add text, you can still add clip art, but it just doesn't look right. So we haven't figured out how to get around that problem. I don't know if it's possible to get around that problem. I don't know if we care enough to actually put all the effort it would take to actually try to do that. Binary responses from the servers are hard. You end up just doing binary compares at some point, and that really gets moved down into your unit tests. We do a lot of image manipulation and image generation for our text and our clip art and our uploads. So that's been a big problem for us. Uploads are only supported in some browsers. When I say some browsers, I mean Firefox, at least unless you're willing to write native browser components or whatever it's going to take, which at this point, that's just something I have to test by hand every time we want to do a rollout. And I think the most important thing here really is that the DSL really is a living piece of code. It really is something that you have to treat like it's an actual system. You can't just develop it once and expect it to be no maintenance. You're trading the maintenance cost of your test for the maintenance cost of your DSL. And I really think it's a much lower cost, but at the same time, this isn't a magic bullet. It also, I mean, I think going along the same lines is not a magic bullet. This is really also something you have to develop yourself. I mean, it's once you start on it, and if you, at least using Selenium on Rails, we found it was very easy to do. And there were some challenges which I've gone over, but there's no piece of open source software I can give you that's going to allow you to test in your domain. That's kind of the point. Really, you want to build something that's specific to your application in the language of your business that makes it easy to write tests for you, not for other people. So actually abstracting this out and moving it into an open source app would be really hard. Okay, so here's my summary. My two rules are don't try to write Selenium tests by hand and do try to write them in some other way. We suggest trying to use a domain-specific language. If you want to write your own framework, I think that's a good idea too, but at some point you just can't try to write them by hand. You have to have some other way of actually building them. Okay, that's all I got.
Is it working now? Oh, okay. Hi, Doug.
Hi.
So, Doug, what kind of success have you had with having non-technical people actually maintain and write these DSL-specific tests? You mentioned that they're living pieces of code, right? So I'm making an assumption, probably a poor one, that at CustomInk, because of this, you can actually do more rapid releases and deploys because you don't have to do as much black box testing. But
Right.
when you're adding new features, how fragile are the DSL specific tests, and what kind of traction have you gotten to have non-technical people actually roll up their sleeves and start editing and manipulating these tests to in lockstep with the new functions that you've added?
What we found that, for the first part of your question, we found that adding new functionality in general doesn't really break the tests. The way that we're doing it, the way that we name everything based on the specific links, unless they're really gigantic changes, we found that in general, it's just a matter of adding more functionality into the DSL itself, more commands. And really, we've approached it almost like unit testing, where when our front-end developers actually work on it, they just write new commands as they go along. Because I think another reason that we didn't use Selenium, the Selenium remote control to send one command at a time is that our developers are using this to test their actual work. Our JavaScript guy uses it basically like unit tests. We've had, as far as how much traction we had with non-technical people writing it, it's been more limited there. I think that they really have to be interested in trying to work with it and trying to understand it for people to actually write it. What we have found, though, is that non-technical people can submit. We basically just give them a format we want them to submit it in that looks almost exactly like the DSL, and then we can just put it in there to try to reproduce their problems.
Hi, Doug. You mentioned you're using a lot of wait for conditions in your scripting, and I'm just curious, when those conditions aren't met, do you recover gracefully, or do the scripts and the web application get out of sync?
So when a test is actually actively running and a wait for condition fails?
Yes.
What generally happens is, usually when a wait for condition fails, it means that we're going to get a timeout because something returned more rapidly than we expected. Or more slowly than we expected. So it's normally going to time out, that test is going to fail, and we're going to go on to the next test. So we're going to get a failure in that test, and we're going to have to go back and look at it.
How do you go about avoiding running these things serially. That is, you mentioned distributed testing, and how do you maximize the performance of these things, especially with the number of weights that you put into these Selenium tests?
The way that we run it remotely is we still do use the Selenium row control, but rather than sending individual commands, we just send it a URL, which it pulls back to and runs all the commands in that test suite. So we deploy to our testing servers, and then we have the Selenium row control, and we have, I want to say, a dozen VMs that it sends out a request to that then run to load the page, load the actual test suite off of our staging servers, and then run all the tests and post the results back to a URL.
Sounds like it could be another presentation.
It kind of could, but as far as wait for conditions, we haven't found that it really is that bad. We found that the XPath was what was really slowing us down. The CSS locators made it go a lot faster because we find that with the wait for, if they're waiting fractions of a second. So it still goes pretty fast. We probably have 200 tests, and they probably run in IE6 probably in 2 hours, but in Firefox in 45 minutes.
Okay. You may have answered some of these questions, so I may not have as many as I thought. You mentioned about non-technical users writing tests. What happens when a non-technical user comes up against testing a requirement that they can't find a way to express in the DSL?
They have to ask us for another command, basically.
Okay.
But the commands are simple enough to write that anyone on the tech team can write them. I mean,
Okay.
Implementing the DSL commands is very straightforward.
All right. And the other thing, I think you may have covered a little bit about this, but are there any particular techniques you use to make sure the DSL is maintained along with the code? Like Simon mentioned with WebDriver, you can, because the page objects are written in Java, you can actually link them to the objects that are actually being tested. So when the API changes, it just won't compile anymore, and someone has to go in and change the page objects. I know with Python or Ruby, you don't tend to have that safety net. So is there anything in particular you guys are doing to?
Well, I think there are actually two issues sort of wrapped up in that. I think there's one thing we do is we do code review all of our tests, basically, probably twice a quarter, just to make sure that there aren't obvious other DSL commands that we need to move down into the language itself and out of the test. So if there's too much complexity creeping into any of them. And the way that we find out that basically an API has changed or something is broke is when we try to run the tests, they fail. And we run the test basically every day at this point. So when they fail, we know that something has changed, and then we have to go in and look at it. But you're right, we have no static compilation to tell us that something's broke.
Just one more. What's your ratio of people maintaining the DSL to working on the application itself?
I would say that only myself and our JavaScript guy are actually adding commands to the DSL or maintaining the DSL. I think the overhead is very, very low right now. I think there was a bigger investment up front to actually get it up and running. But now that it's there, I think that, I don't know, I'll say a quarter of one person's time is being spent on it, if not less.
And that's out of 5 people?
Out of 5 people, yeah.
So, okay.
Right, so I've actually been working on a DSL myself, and a couple of challenges that I've had are doing negative testing in the DSL, and I've forgotten the other challenge I was going to mention. So how do you handle doing negative testing with the DSL?
Well, I mean, the negative testing is hard just because then Selenium tests are either going to fail or you have to have not conditions that are going to pass, which is how we've handled it, is basically we've put weights and things like that in there that we expect to fail, and then basically reverse the condition in the actual DSL. But it's really hard because once it compiles, so let me step back. So we have to push it down to the JavaScript is the answer.
Okay.
Because otherwise Selenium tests are going to fail, and we don't want any red on it. Otherwise, people just start to ignore the red, which we don't want.
Yeah, exactly. That's the same issue we've run across too, is we don't want to expect the test to fail.
There is one main reason why people start to use DSLs, and I think you mentioned it, is to make non-technical people actually use it. Now that reminds me of computer science, software engineering in the 80s, when there was the hype for doing end-user languages, and suddenly all the non-technical people will write the software they need for their daily uses themselves. We will just give them simple commands. The same is now reiterated in testing for non-technical testers and DSLs. Why do you think DSLs will achieve what end-user languages failed in?
Because I don't think that our goal, at this point at least, is really to make it so non-technical users can test. It's to make it so that we can write tests very rapidly.
But couldn't you be faster if you did that through an API?
I don't really think that we could be faster through an API. Well, at some point, it's two sides of the same coin. At what point does a DSL actually become an API? Because I think that that's how we started. We started writing an API, and we realized that it, just by changing the syntax a little bit, it could become much more readable. I think that it's always going to be a challenge to get non-technical users to actually write tests, and they're only going to have to be people who are really interested in doing it. We have had a little bit of success doing that, but I mean, it's not as easy as just putting something into someone's hand and saying, okay, now you're going to write tests.
There is a huge difference between an API and the DSL. As the one question before did mention, in an API I do have the compiler who tells me if I'm messing up something in my test which is incompatible with the API of the utility library or whatsoever. And the other thing is that I get the full expressive power of a programming language to formulate my tests in, which I shouldn't have in a DSL.
Well, in our case here, we're a Ruby shop anyway. We have no static compilation anyplace, which is the reason that I say that I think it started as an API and then worked its way up to a DSL, really. Because, I mean, that's how we initially thought of it as well.
It is essentially the API that you're talking about.
Right.
Can I add a comment to that? I think most of the people in the DSL camp these days would say exactly the opposite of what you're saying, in that DSLs are typically meant for people on the business side to be able to read, not to write. And I think that's the fundamental change in what people are advocating. So people on his business side are kind of writing tests, but they're really not. And I think Martin Fowler, not to be a Fowler about as a thought worker, but he has a great thing on InfoQ from a presentation. It's on there, you can find it, about DSLs and why the vast majority of the community now thinks that they're for read-only purposes, and we've written them for clients in that same sort of vein, and it works.
That question. Hi. Do we support state detection?
What do you mean by state detection?
Which means like if an event is triggered, right, we reach a certain state and we do a validation. Mm-hmm. But what if a state changes based upon the input that we provide? Because like example, like we have a stock ticker, right? Mm-hmm. That could actually fluctuate within a day. So once we know that we've reached a state of like a drop in the stock price, we've performed certain validations, and an increase in the price, we perform certain validations. So at runtime, can we do a state detection and then perform a validation? Because the validation could always...
At runtime, you cannot detect a state. All the state has to be done statically up front, at least in the way that we've implemented it this way. You might be able to do more runtime state detection if you were to make it all run, just send a command at a time through Selenium RC. But that's not the way we've chosen to do it at this point.
Oh, okay. Thanks.
2 quick questions. One, what was the initial investment of time in order to get this up and running?
Well, I think we probably spent 2 or 3 weeks just figuring out what not to do. And then after that, it was probably another, 2 weeks to have our first test running. But once we had our initial test running, let me put that another way. So after the first month of actually writing tests and working on this part-time, it became much, much easier to write DSLs. Once we figured out how the page state and the click transitions were actually going to work, it became almost trivial to actually write them.
Second question, Are you able to use tests like this to do things such as testing or verifying things like, for example, someone's buying a T-shirt? Well, there's going to be transactions based on credit cards that have to go and do data out to another party.
Right.
Is there a way to use these kinds of tests to verify those kinds of things? In other words, the data is going out, the data received is coming back is correct, and all those kinds of things.
Well, right now we have integration tests on the server side that do a lot of that. But as long as you have test data which you can enter, as long as there's a testing state that you can put your credit card transaction system into, then you can, because you can send it through. You can send through what you consider the valid test credit card number, and then verify that the state it comes back in is correct. But really, the place to be doing that, at least in my opinion, is more on the integration testing side on the server side.
Hi, I have two questions. First one is, how do you manage all the different objects in your website? Like, for example, if your UI engineer decides to add a certain text box or change the property of a certain widget, do you have a process to deal with that, or does someone just have to manually go into your function to manually change it?
Normally, it's whoever makes the change has to go through and change all the tests.
Okay.
So, and let me put that another way. That's badly stated. Not all the tests has to go through and change the commands in the DSL to make them work. That is, when we're making changes on the front end like that, before you can commit, you have to run Selenium and have it run to the end. So generally people will commit it, if they're making big changes like that, they'll commit at the end of the day.
Okay. And my second question is, your website seems to have a lot of graphics. Have you done any automation to check the graphics, whether it looks right or whether it looks the same as last time?
We have, and again, it's all in our integration test at this point, and we just do binary comparison. I mean, that's
Like bitmap?
at the bitmap level, yeah. So I mean, that's the only way we found to be able to do it. I don't think it's practical really to do it in the UI. I'm sure you could with screen captures of some sort and binary comparisons, but right now we're handling it on the integration testing side.
Thanks.
Do you find many situations where the level of abstraction in your DSL breaks down, and yet you want your non-technical people to be able to work with this level?
Generally, when we do find that the level of abstraction breaks down and we want to test more finely grained stuff, but in general, we don't find that non-technical users are trying to do that. Okay. It's much more that that's stuff that developers are trying to do, or that people actually writing tests are trying to do.
Right.
You gave a very convincing example of domain-specific language being appropriate for solving a problem. Now you also mentioned that the DSL itself is a piece of software that needs to be tested. Can you tell a bit more about your testing strategy for the DSL itself, for the testing infrastructure?
Well, it's all just written in Ruby, so we just have basically unit tests to do it. Unit tests and mock objects.
Hi, Doug. Do you have plans to make your DSL more data-driven, or you don't want to go that route because that will make the DSL more technical to write? Or
we do have plans to make it more data-driven, because right now one of the things we don't handle a lot of, one of the areas that's not covered very well is really saving and loading of data. So, but Selenium on Rails has something built in called Fixtures, which basically try to manage the database state before and after the test is actually compiled. So we're probably going to try to use those to actually do it. I think that you could make it a lot more data-driven. The only catch really is that all that data has to be compiled and built in before the test actually starts to run, unless you're going to use Selenium row control.
So this is for the person who is asking, what do you do if the non-technical person doesn't have the command to write or something like that? So we use DSL for our testing, and what we generally tell the non-technical people is that, yes, this command is in the process of we're building it, but because it's DSL, you can just go ahead and author the script because it's DSL, you understand what to write, and this is the command. Just use it, write it, and tomorrow when the command is ready, your script will magically work.
Right, the only downside of that is that they just really can't run it right then, which they often want. They want just instant gratification.
Hi.
I noticed your DSL was still at a pretty low level, though. You said click this and click that.
Right.
Do you have any plans to introduce something that's at more of what I would call at a business level, which lets a user say, create a black T-shirt with these words on top, with the diagram from this location in the middle and these words on the bottom?
Well, we've talked about doing that a little bit, and at some point, we're trying to keep the DSL commands from becoming very complicated. And I don't think that the test that I showed you is really at the right level of abstraction. I think it can definitely be up a level or two, but I would much rather have them say, you know, load a black T-shirt, add this piece of clip art, add this piece of clip art, add text, and then verify that a quote of 33 larges comes back as $2 a shirt, rather than having just one gigantic command which actually does all that.
Okay, that's equivalent, yeah.
Yeah.
Have you ever considered like building a UI so that the business user can just take on all those DSL command and basically building another layer on top of it so that, you know, that's how I have done it in the past, is build another layer and then basically just give them drop down, and then now they can create almost manual tests that can be used in an automated fashion also.
I guess we haven't really thought about doing that. We're a small team, and we feel like sort of the DSL overhead at this point is enough anyway. So adding another layer on top of that would just be one more piece that we would have to maintain and take care of.
Any more questions? All right, Doug Sellers, thanks very much.